Hello, my name is Egor Shulgin. I'm a master student at KAUST. Today, I will present our paper called ADOM, Accelerated Decentralized Optimization Method for Time-Varying Networks. This is a joint work with Alexander Rogozin and Alexander Gasnikov from Moscow Institute of Physics and Technology, Dmitry Kovalyov from KAUST, and Peter Riftarik, who is my research advisor. We consider an undirected network G with V being a set of nodes, 1 to n, and E being a set of edges. Our goal is to find a solution to a finite sum minimization problem over Rd, where each data describing function fi is available to the corresponding node I only. In our paper, we focus on the case when each function fi is L smooth and mu strongly convex. In our setup, decentralized communication is done only across edges of the network. For example, node 7 can communicate across edges with nodes 3, 6, and 8. We are going to use the gossip matrix W to represent the decentralized communication. This is n by n matrix, which satisfies 3 properties. It is symmetric, positive, semi-definite. Wij is non-zero if and only if I is equal to j, or I is a neighbor of j, and kernel of W is a consensus space. Decentralized communication can be represented as a multiplication of vector by gossip matrix. Indeed, ith component of Wx is a linear combination of xj for all j's that are neighbors of I. In this work, we study the situation when the links in the communication network are allowed to change over time. Such setting may be relevant for sensor networks where changes in the link structure occur when the sensors are in motion and due to other disturbances in the wireless signal connecting pairs of nodes. Mathematically, time-varying network is represented by a sequence of graphs where every gk is a connected undirected graph with a certain gossip matrix wk. Next, we do a few reformulations of the original problem. Firstly, we consider an equivalent lifted problem with consensus constraints. We denote the objective function of the lifted problem by capital F. It is a well-known fact that lifted problem has an equivalent dual formulation where f star is the Feinfeld transform of function f. For the last problem, we apply a carefully generalized version of projected Nesterov gradient descent. Our analysis requires several new insights and tools. We rely on the new observation that decentralized communication can be seen as the application of a certain contractive compression operator, which are often used in distributed learning to tackle communication bottleneck while reducing data transfer. The highlighted operator is linear, but may be biased. This idea allows us to design a bespoke error feedback mechanism for achieving acceleration. Here, you can see a review of decentralized optimization algorithms capable of working in the time-varying network regime with guarantees. Complexity terms highlighted in red represent the best node dependencies. Our method is the only one with the right dependencies in all terms, and in this way, it achieves the new state-of-the-art rate. We compare with the best previous methods on the L2 regularized logistic regression for different optimization problem and network parameters. In the first row, he is fixed and approximately equal to 30. So we vary only kappa. In the second row, kappa equals to 100 and he is varied. To summarize the obtained results, ADOM converges linearly and outperforms all other methods for every set of parameters as predicted by the theory. You can find much more experiments with synthetic, real data, and real networks in the preprint available on the archive. Thank you for your attention.